There we go. Thank you, everybody. This is the, what is this, August 2024 installment of the Microsoft Data Platform Continuity Virtual Group. With me today is, how can we present you? You're the OG, in my opinion, the best performance tuner for SQL Server in the world. This is Thomas Grohser. If you've never seen him present, grab some popcorn. This is going to be an amazing 30 years. Good grief. It's going to be an amazing session. So TG today is going to be talking about SQL Server HADR in the current year of 2024. So with that, I'll turn that over to you.
Yeah, thank you, David. I hope everybody can hear me and see my screen. And yeah, as David says, we're going to talk about HADR. I'm with SQL Server for about 30 years. Let's go to the Who Am I screen while I'm talking. And over these many years, I noticed one thing, that the requirements that corporations and people have on their databases have changed substantially. When I started with SQL Server, the concept of having like a high availability or DR was like a non-existing thing. You probably had one SQL Server somewhere in a corner running on NT 3.51 and SQL 4.2. And yeah, it's a while ago, but it went. But then over time, requirements got tougher and we had to learn how to keep up with the demand, what people want. And this session basically quickly gives an overview, what is available, which tools we have, discusses the basic ideas of my point of view of high availability so that you don't understand what I'm trying to explain. And then I try to go to 3 or 4 very simple basic scenarios, which are the ones I see most out there. Yeah, not the crazy ones I usually work on where I have like 16 machines in a cluster or something. No, I'm talking about the 2, 3, 4 node, maybe 5 node systems that someone would actually build in out there. Yeah, as I said before, I'm with SQL Server for 30 years now. SQL Server is 31 years old, so I'm not there from the beginning, but I joined very early. And yeah, I'm doing a lot there. So it's happening. Before we start, I always like to kick it off with a little bit of fun. Another thing I have had to learn over the years is how to compare stuff, because if you want to figure out something, you have to compare like the typical English phrase of apples and oranges. Yeah? So you want to compare apples and oranges. It's not easy because hardware vendors and product descriptions and everything make it hard for you. So you might find these apples and oranges in all kinds of mixed up fruits that don't really work, or you might find an apple with an orange on the inside and the other way around, and then you have to compare that. Yeah? While they are both probably very similar, they can be very different. And then the last problem is if you have a clear apple and an orange, the company that actually makes them will put some decorations on it because they call that marketing. So not that easy to compare stuff. And before that, thing is, what can go wrong? And the answer is everything. All the things you thought about and many more. And if you're doing this for 30 years, a lot of stuff happened. So let's see. The most simple one everybody thinks about is some single component failure. A hard drive fails, a memory chip goes bad, a network card blows up or something. Then a whole device might go wrong, a whole server, a whole network switch, whole storage array. That's the thing. Is also the first two, there's many decades of experience how to protect against these. A whole data center failure, Yeah, we're learning how to work with that when we're in the cloud, because they usually have a tendency of, if something goes wrong, it goes wrong very massively. And even if you're on, in my years, I had cases where a whole data center lost power or got cut off the network or something like this. It can happen. Um, Another one, and here is it where most people stop thinking about when they plan how they do stuff. The network between two data centers can fail. Yes, network teams try to make everything super redundant, but the problem is you never know, because you might be buying two lines, but they might be physically virtually squeezed into the same fiber optic line, and you have almost no way of reviewing that, because even if you buy it from two different tier one carriers, in some areas they share infrastructure. That's not thing is, yeah, there's no point for each and every carrier digging fiber optic lines everywhere on the global planet. Yeah, if someone put a line somewhere in a area that is not densely populated, the other guy is not going to put in their own. They're going to just trade a few fiber optic lines, and they might end up in the same cable. So network failures between data centers happen. Um, Another one is data loss or corruption. Yeah? Nothing is wrong. Yeah? Just some software error. Might be inside SQL Server, might be in your application, might be some human error that they forgot the where clause in an update statement. Yeah? And a couple of gigabytes of data are worthless. Yeah? And there is way more that can go wrong, but I thought we only had 1 hour, but I was informed I can go over as much as I want. So maybe we talk about a few more. Yeah. And one hint, human error and sabotage are two of the big ones. Sabotage, you're not thinking about it till it really happens to you. Because we have a tendency to believe the good in human, but it can happen that someone is. And one I didn't put in here, which is my favorite when I talk about SLAs, is the multi-government strike against your company, which I lived through in a company I worked for many, many years ago, where 6 countries had SWAT teams in our data centers at the exact same time and cut our fiber optic lines. We were down for about 28 seconds till the seventh data center they had no idea about went online and continued. So we got lucky, but it can happen depending who you work for. So service level agreement. You can't think about high availability unless you know and you have written down what you actually need. Because if you start just randomly building stuff, it's not going to go anywhere, and it's never going to do what you actually want. Because if you ask 10 people in your company what's important, you get 11 different answers. And that includes when you ask the 3 people that are in charge of the company, then you will get at least 4 different opinions from them. Yeah? So what you have to do is you have to put certain things in. Recovery point objective. So how much data can you lose? And this can be, I worked for companies where it was absolutely zero. If we commit a transaction, we cannot lose it. There is no way around it, all the way up to, yeah, if we lose the whole day, it costs us some money, but we will survive. Yeah. So 24 hours on one hand, we don't care on the other hand. I have worked not on the whole set. I had data sets where literally the answer was, we don't need backups. If we lose it, we just download it from the vendor again. There's no point in backing up that data. If we lose it, we just get a new copy of it. So that makes a big difference if you have to think for this. Recovery time objective is, how fast do we need to recover? Seconds, or is it fine if we're back online next Monday? Yeah, and both could be the case. If you run a 24/7 web shop on the interwebs, you might want to be back in within seconds, especially during Christmas sales or something. Yeah. If you are a bookkeeping company that manually inserts the data or so and something fails, beginning of next business day is probably fine. People will find something to do for a couple of hours if they can't use the systems. Will they complain and be unhappy? Sure. Will it ruin the company? That's always the question. Yeah? There's no point in spending millions and millions of dollars or euros to build something that doesn't give you an actual advantage or makes your business more safe. Yeah? If your business, I've once worked for a pharmaceutical company. They literally said, if we are back in 3 days, we are fine. For 3 days. Day 1, people will clean up their desk. Day 2, people will organize their filing system. Day 3, they will take a day off. Day 4, they should be back in the office working. Yeah. But you would not think that a pharmaceutical company can survive 3 days without computers, but they can, and they tested it. So performance, yes. In my opinion, performance is part of the service level agreement and is part of availability, because it's great that I can still browse the database, but if it takes 2 hours to get the data back, that's not available if I need to render the web page in 10 seconds. Right? So that's not a thing. And the last part is, of course, security, because if I don't protect the data, it might not be useful anymore, or if the competition already has it, the advantage that we had by collecting the data or using it might not be here. And as usual, much, much more in there. Just these are the main ones that have an effect on availability and high availability. Why do we need SLAs? I already said it. Management and your coworkers, you need to understand and agree to the same reality. 100% availability is impossible. Yeah, it's just not. Can you achieve 100% over a certain period of time? Easily. Can you guarantee it? Absolutely not. Yeah. It will help you request and argue resources you need. And with resources, I mean money that you need to spend. If your company wants you to be able to fail over and have no performance degradation to your DR side within 10 seconds, they need to shell out some money for that. Yeah? If they are fine that when you go to DR, you run at half speed, and it can take 3 or 4 hours to get there, then you can use the previous hardware that you used in production to run your DR side. Perfectly fine. Yeah. And of course, to avoid lawsuits when it comes to discussions that you guaranteed something and then you can't hold it up. And if you have it written down, it's usually much easier to avoid them. What is available? That is also the big discussion point. And if 2 people are bragging who has the better availability, and you listen to them for a while, and then you try to ask them, okay, what do you define as available? And then you get 2 completely different answers. Thing is, my number 1 pick is planned maintenance part of availability or not? Yeah, because if someone tells me they have 5 nines and then they tell me, yeah, but if you have a plant downtime, it doesn't count. That's great. I would immediately announce a downtime from January 1st to December 31st with the capability of running the systems while we are down. And my bonus is secured. No, it's not what it is. Yeah. The first question for me is always, is an application or a service available when I can start it? Doesn't mean it's working. It just says it's running. But I've seen places that make the availability report based on if a process is there or not. Can I log in? That's great. I have SQL servers I could log in with any problem, but then couldn't do anything with them. Can I browse the data? Yeah? Or does SQL crash while I'm browsing it, or disconnects me after 10 seconds or something? Yeah? Can I browse it, but it's so slow that it doesn't make any sense? But technically, I can still browse it. So is it fine or not? Can I change data? Yep. System transaction log 100% full. I can read all the data for 10 years and have no problem. If it's a read-only system, who cares? If you want to insert new data and it's not working, you get that. So you get the idea of what's going on there. You have to define what means available. And don't always make it as flexible as you can. Like 95% of all transactions run within agreed time frame between 8 a.m. and 6 p.m. or something like this. Try to limit it as much as you can so that you have buffer zones where you can actually do something, because there will be the time where you have to fix something or do something and hammer the system in a way that it cannot respond as it's normally doing. And if you have these little loopholes in your SLA, it's fine. And also 99% of the companies do not do 24/7 business. Even the ones that do 24/7 business, they usually have partitioned the systems around the globe in a way that like follow the sun, that the data that is really needed to process is usually locally on the same continent, or at least in the same time zone region, like the Americas, Europe, Asia, and not like you're not serving a request in Japan from a server somewhere in the middle of Europe. That just makes no sense. It's literally on the other side of the globe. So for me, the definition of available is if it performs all operations at the desired performance at the time needed. That's my definition. If that's the case, it's hard to measure that, but it's possible. Or it performs all operations according to SLA if you have a nice and have that specified in your SLA. So the next thing is I want to quickly talk about the difference between high availability and DR. And we might come to a very shocking conclusion here. So this is high availability. If you're in a 747 and one of your engine literally burns to the ground while you're in the air, that plane just keeps flying and has no problem reaching its destination. People might have mild heart attacks and panic attacks and everything else inside the passenger cabin, but the plane itself is designed to fly with 2 of the 4 engines, and I think it can still safely land if there's just 1 of the 4 engines available. So that's high availability. Something breaks and you keep going and you don't stop. This is disaster recovery on the other side. If you jump out of the plane, you have to land, walk back to the airport, get into a new plane, and then start flying again. That's disaster recovery. Still, everything that's important survives, and a few things that are meant to break will break, but it works. And that's the difference. So high availability means you keep running, and disaster recovery means you start again from a defined starting point that you created to have basically a thing. It's like when you're playing a game and you die and you go back to your last good known thing to your last save point and you start from there. Last resort is something that nobody else but me uses, but in large things is last resort means the third thing is if your high availability failed, your disaster recovery failed. Last resort means is you start fresh from scratch. You have nothing except a tape with the data on it. And then you start like calling your preferred vendor and says, hey, we need new servers. And by the way, don't ship them where we had them last time. We bought a new building and we'll start from there fresh. Yes, we send you the check up front. Thing is, in the binary world of IT, there is no real high availability. There is only DR. But we make DR really fast, and it feels like high availability. This typical, you have a problem with SQL, you have some magic failover thing, in 10 seconds it's available again, you retry the transaction and everything is fine. People define and use the term high availability for that. And while I'm pointing out here that it doesn't really have, and no relational database has actual HA. They all have very fast DR, they have regular DR, and then they have backups. But thing is, all in-flight transactions, when you have a failover to a secondary systems, are canceled and rolled back. And that is technically not 100% true anymore. And then they need to be retried on the secondary system. And that needs to be into your application. So there is no way in any database system that the database would fully do the high availability work for you. Your software developers, your third-party application must be able to deal with that failure. So if the database fails, they have to wait a couple of seconds and then try again. Yes, there's the stupid applications that just immediately try again and then do it for 1,000 times in a row and make you a failover and horror because they keep trying to do stuff that they are not ready to. But clever ones have like a 5-second, 10-second, 15-second delay every time, and then it goes slower and slower. Thing is, yeah. Microsoft is working and it's already released. Backups and index rebuilds can already be continued on the secondary after a failover. And this is major. Just imagine you have like a multi-terabyte database where the backup takes like 6-7 hours. And after 3 hours, you have to fail over to the DR side or have a high availability event. And then you have to start that backup again. That's a lot of work, or an index rebuild that takes a whole day or something. Yeah? And in the latest versions of SQL Server, there's already mechanisms in there where you can start the backups and the index rebuilds. If you use that feature, are a little bit slower, but at any point in time, if your environment is prone to lots of failovers, you might want to choose that option to continue on the other side. I'm not even remotely saying that they will ever get to a point where each and every tiny transaction can do that, because that is probably more overhead than it's worth. But it's good to know that they're working and understanding that the long ones are really painful. And let's put it this way: if a backup takes 6 hours or 6 hours and 5 minutes, but if I have a failover after 5 hours and 59 minutes, I only need another 7 minutes to finish it, or need the whole 6 hours again, I choose the 5 minutes every day easily over that. Yeah. Next one, availability is not just a recovery time objective. Yeah, there's no point. Thing is recovery time or recovery point, performance, security, everything we talked about together is the availability. There's no point that your database is online, but now everybody is sysadmin because you had no idea which permissions were configured on your DR system. That's not how it works. You have to have everything on the secondary system must be working again, and the performance must be within an acceptable or upfront agreed range. Yeah? To achieve availability, it's always easy. Yeah? Having a system running is not things. Yeah, guaranteeing availability is very, very hard. Yeah? And again, I laugh all the time when people tell me, yeah, we have this 6 or 7, 9 storage system, and with that we have no issues. And I was like, no, you don't, because if someone runs an update without the work clause and you have to recover 3 terabytes of data and your restore is going to take 6 hours, it doesn't matter how many 9s the storage system has. It's the whole package. You cannot just look at one thing. So, and a lot of people confuse luck with availability, and so I worked for a company where the whole IT department's bonuses were tied to the actual achieved availability. So we had like, and I'm doing a random number here, yeah, not what it actually was. Yeah, so we had about 100 people in IT, and the bonus for the whole team would be 10 million, minus 100,000 for every minute we are offline in that year. Okay, so we can be 1,000 minutes offline. then we have to go to our savings accounts to pay the company back. But anyways, 1 year we managed 100% availability because we were great. No, we got super lucky. Yeah, nothing broke for a whole year. Yeah, normally we made it to like 90 99.7 or something. Yeah, so a couple of hours down every year. That's still good, but that's more realistic. Yeah. And this brings me to the most important thing is once you have these high availability requirements, you have to be able to find that something's wrong. Yeah. The good thing is usually the more severe the outage is, the faster you will find it. If the server is gone, it's very easy to find that. Yeah. If you have some hidden lock on one row in some table that prevents each and every query from somehow finishing, and that lock comes and goes every 7.5 seconds or something, and you have no idea where it comes from, that might take much longer to figure it out why your system is not working. Yeah? Or you have this awesome network card that 3 times a day designs to disconnect the server from the network, and you have no idea why. And stuff like this. Yeah. And then the other question is, how often do you check your system health? I always like this default settings of most monitoring systems that say, hey, every 5 minutes, we check the systems. Like 5 minutes is a long time in computer things. Yeah. So with 5 minutes, you can't do 5 nines because that's only 3 minutes. So thing is, and my example is always, so if you give me 5 minutes, you check every 5 minutes. I'm a clever DBA. I'm looking for the query from the monitoring software. And once it came in and went back to the monitoring software, then I have 4.9 minutes to do a failover. And based on your definition that you monitor every 5 minutes, I have no outage. We all know that's not true, but hey, if I just killed someone that was running for 3 hours in a complex query, yeah, nope. Monitoring said we were 100% available all the time. Yeah. So that's just not usable. Yeah. You have to find something that actually works. So big surprise there. Regular monitoring does not. Yeah. How long does it take to react to a failure? That's also the thing is if you have your automatic failover and you have a way for it to actually work, then we're talking seconds. But in a manual failover, you have to figure out who to call. You have to pick up the phone. You have to be able to talk to them. Yeah? And I had cases where the surrounding sound was so loud that they couldn't understand what we were telling them. They have to connect to the network, which is also sometimes challenging. They have to log in and then work on the problem. And this could be 10, 15 minutes. And 10, 15 minutes is a lot of time. Yeah. So I worked in places where we normally had the on-call person within 15 minutes must be able to be working on the problem, which is something you can easily do. Even if you're in a supermarket or so, you can walk outside, go in your car, open your laptop, VPN in, and you're fine. But when we had major events where we knew that we were making 10, 15 times as much money as a normal thing is, we had the on-call person sitting in the office. Yeah. And they were better within like 1 minute back at their desk. Yeah. I mean, you have to give them a bathroom break and all that, but it's much faster than being somewhere on the outside. Yeah. So surprise again there. That is something a lot of people do not plan into their high availability concepts in. How long does it take to do failover? It depends. You will like my summary, but thing is, backup restore, once you're in that phase, we're talking hours. It might be days. If you have triple-digit terabyte databases, that might take a while. Log shipping, we're talking minutes. You have to catch up, and hopefully everything is in sync. And thing is, clustering and failover cluster instances, it's somewhere between seconds and minutes. And you never know how long because clustering is a very strange procedure. You're basically yanking the drives out of one system and plugging them into another system. It's all done virtual, but it's still thing is. And the fun part about clustering is unplanned cluster failovers are always faster than planned ones. Planned ones take way longer. Because in planned ones, you have to unmount the disks and mount them on the other side. If your primary machine just dies, all you have to do is remount them on the other side, which is usually the faster process than the unmounting. Because in the unmounting, they actually have to wait for all the writes to finish, which can take hours. And not anymore since Windows 2012. Check disk is no longer a nightmare. But before Windows 2012, you had a cluster failover, and you wonder why the cluster is not coming back. And then you go to the console. Windows is still in text mode and doing a check disk and says it's going to take another 3 days to finish that check disk on that 10 terabyte volume or something. Since 2012, that's not an issue anymore. The longest check disk is like 6 or 7 seconds, so that's doable. Yeah? And database mirroring and always on availability groups fail over in seconds. The problem is with failover, the failover is not the part that usually takes the longest. Once you fail over, the database has to recover, and this is where the variable really comes in. Because everything else you can plan for. Database recovery depends on how many in-flight transactions have to be rolled back. Just imagine you just did an insert of a 1 billion row table and you're 99% done, and now you fail over. All the allocations, everything that was done has to be rolled back. That can take hours. Or a big update that touches every row in your server and in your database, in your table. This can take forever. It's much better in SQL 2019 with advanced database recovery, which is something when fast failover is a requirement, I would turn on. It comes with complications and drawbacks. Your systems is going to be slower, because tempdb is no longer running in tempdb. And when tempdb gets moved into your own database, tempdb becomes much slower because all the optimizations they did for tempdb are not applied to your database. So you're basically writing twice as much temp information into your log file, and therefore everything that inserts data into a temp table takes twice as long. But again, what's more important? So it's somewhere between less than a second and several weeks. The longest one I had was 76 hours. 76 hours, that's 3 days. Yeah, that's a lot of yelling from your managers and his boss and his boss's boss, and then the guy above that, and then one more above that, because they will all know you personally from yelling at you for hours. But nothing you can do. The fun part is it didn't take all 76 hours, because after 12 or 14 hours, we finally found the developer of the database, and he says, oh, not a problem, just give me an empty one. That database was immediately removed from being a DR, having a DR procedure with high availability. All we had on the secondary side was an empty database with the schema in it. And when they failed over, that's all they needed. They could have recovered the stuff within like 2 minutes from scratch, and we were rolling back things. The reason we were rolling back is there was a transaction 4 weeks old that was still not committed, and so it had to go through 4 weeks of transaction logs. This is the problem when you work on large machines. A 4 week, you don't truncate your transaction log for 4 weeks. That doesn't bring down the server. So again, surprises can happen here. So how can you check availability? Monitoring. How often do you probe? Every 5 minutes, every 1 minute? The problem with monitoring is it's such a strain on the systems. I had some funny thing. We were migrating from one monitoring tool to the other. And so we had 2 of them installed at the same time and hammering the systems too. And what monitoring tools normally do is they exclude their own traffic and their own workload from the reporting. But if you have 2 of them, they only exclude their own crap, but not from the other guy. So we finally saw that the system was literally doing 60% of its workloads were the monitoring software. So lots of changes in the monitoring software. Be careful there. Yeah, the monitoring tools exclude their own workload when they report to you. So you have no idea how much they actually take up unless you look at it from a second viewpoint. The second one is guessing. And the point why I put that guessing thing there is as good as monitoring. As I gave the example before, if you probe every 5 minutes, you have no idea that a whole failover happened, because I can fail over a machine in a planned way in less than 5 minutes. So guessing is as good as monitoring. So don't do either one of these two. This can give you rough numbers, but never the truth or anything that's actually what's happening. The best way to do it is your application logs if it can do something or cannot do something, and logs how long it takes each and every time. So you can actually calculate what is my normal time to do an operation and why is it suddenly taking 30-40% longer, or why is it suddenly failing. So if your application logs this and you can have that collect these logs and analyze them, that's how you can actually find how many how often the systems actually fail or do not fail. Because honestly, if a system is only using the database every 10 minutes for 10 seconds to write some checkpoint or something, or some summary into the database, they have a great retry logic. So if it fails over in between, the application might never log that it's not working. Yeah. Also not good because you're not knowing that you're constantly failing over. But on the other side, it wouldn't matter because it still works. I worked once on a phone system that a call center software, and that guy that wrote that stuff had the most brilliant retry logic ever. If a SQL statement did not work or failed for any reason, he wrote it into a text file. And then once a day, someone was collecting all the text files and then rerun all the statements to insert all the missing data or update and do whatever was necessary. They were nicely timestamped so we could order them and then run them in the same order as they would have been in the thing. So if the database is down for half an hour, the application keeps going because they were only recording data. They never needed the data from the database. They only needed to record which customer called in on which line and how long were they doing it. Yeah? But brilliant system, super cheap, and did the trick. And the second way you can do availability checks is you can analyze your database transactions. So for example, I worked for a company where we had financial transactions for about 400 different applications. And the definition was the system is assumed to be available if at least one transaction within a 1 minute period is recorded for each and every one of the 400 different systems. So if we had 399 of them, these 399 will be okay, they are available. The one that doesn't have a transaction for a whole minute is fine. You might say, okay, what if they don't have business? No, that system did 400,000 transactions per second usually. So each one of the should have at least 1,000 per second. So you will find one within a minute, even if it's very low business. There was no problem there. But that was possible there. In many other cases, it's not, because if you have like normal office hours and everybody's only working for like 10 hours a day, the other 14 hours are offline. No. So it doesn't work in all cases. So how do you get availability high? What do you have to do to make that actually happen? Yeah? And the basic way is you have to add redundancy. And the way you do this, you can learn at every wedding on this planet. Yeah? So something fails, there needs to be a backup or a standby that takes over. And if you look at 90% of all wedding pictures, they look like this. So if the first person fails, everybody steps to the right and we are good again. No, just joking. You need spares. Thing is, and this is just a hilarious way of showing it. Thing is, yeah, you have to build up redundancy by adding standby, hot standby, cold standby, any kind of redundant system that if something happens to the primary system, that system can take over or someone can switch over the workload. Yeah? So what companies want since the beginning of time is 100% availability, zero data loss, and full performance, even in a degraded state. Yeah? So that's what they want. The problem is what they're willing to pay for is none of the above. Yeah, everything should be without any cost, and that's just not working. Yeah? So what you normally have is you have some database server, you have some network, you have some application server, a little bit more network, you have your clients, and then you have the end user. Yeah? And that's the these days, that's like, I would say 95% of applications look like this today. There might be that you have immediately an application on your desktop that goes to the database directly, but that is getting rarer and rarer. It's still there, but it's rare. So how do we actually add redundancy to that? Yeah? So what we said, you have to put in a second server. Then you connect that server to the network, but what happens if that network switch fails? So you add another network switch. They need to be connected so they can talk to each other. And then you have to connect both servers here. And here you see that. So doubling the number of servers quadruple the number of network connections. And here is one point. When you build high availability and you make it too complex, it might actually, the availability might go down again because it gets so complex that you have failures because you built a complex system. And I always have a brilliant story to that. Many, many years ago, even before I was working with SQL Server, I worked and owned an internet service provider. And we were having a full redundant system. Every router was there, at least 2 or 3 of them. Every connection was double and everything was crossed out, as you can see here. Yeah. And we had about 1 or 2 outages every month. And they usually took about 30, 40 seconds till all the routing tables and everything was updated and everything was flowing with it finally. Yeah? And most of our customers were perfectly happy. There was another ISP. You might call them competition or the other guys or whatever. Yeah? And they had one gigantic switch in their data center. And everything was connected to that one switch. No redundancy, no other system, but everything was super simple. Yeah, one cable from every device to that switch, and that switch handled everything. And for 5 years, they had not 1 second of downtime with that network. And everybody was going like, you're having all this redundancy. They have much more. And then finally, they had a failure. And it took them 3 hours to get back online. They had a second switch right next to it. They unplugged each and everything and they plugged it into the other switch and they turned the other switch on, loaded the last configuration, and they were back on. It just took 3 hours to plug in, like, I don't know, 300 or something network cables. Yeah, it just took a while. Yeah, but if we are honest, if you look at 5 years, their availability was much higher than ours. Yeah, but a 3-hour disruption in the internet, even 20 years ago, was like a disaster. I mean, just imagine today where everybody's glued to their cell phone 24/7 and for 3 hours, no TikTok. Yeah, I mean, half of the population of this planet has no idea what to do with their life. Yeah? So careful when you start building redundancy. The system's getting complexer and complexer the more you add. And for every layer, it gets harder. And then there are layers. I've never seen a desktop that you can connect, or anybody that actually did connect desktops to redundant switches. Once you're at the desktop level, it's one cable to one switch. and that switch fails, it's not. So, and also, very few people think about that they need redundancy at the human level as well. Because if you don't, what happens if you are on vacation and you're you are needed to do something? Yeah? It's one of the nice things that I love about Europe. When you work for a bank in Europe, you have to go on vacation every year for 2 weeks. And in that 2 weeks, they take your company phone away from you and they disable your login. And they are legally not allowed to let you into the company. They take your badge away, they take everything away because the bank has to prove that none of the employees is essential. Everybody can be replaced. If anybody dies, if everybody gets lost, if everybody decides to buy an island and never come back, the bank can continue. And I've seen very few other companies that actually do that because it's hard to have not these single people, the key man risk to do that. So you want to have a second person that has that. And another thing is, if you have an office or something, enable your people that they can work on someone else's desktop as well. Not with their credentials, but that your credentials work on each and every desktop. So you can, if your machine fails and you need to do something important, you can just find an empty desk, switch on the computer and work there. And that needs to be trained. I work for a company where once a year, I got a text in the morning, don't come to the office, come to this address. This is the number of your DR desk. You have to do your work from there. And there was a clean machine with nothing installed on it or something, unless I did what I was supposed to do to maintain that machine as well. But of course, nobody ever did that. So you started installing SQL Management Studio very quickly to get back into the working part. But once a year, we had each and every one had to test from the DR place where they had a little office where one thing is. Yeah, if you then add a second data center, everything gets even funnier. And I'm not even putting in redundancy on the second data center, but it gets more and more complex. And that's the danger here. So what are the most common scenarios? Again, I work usually for large corporations and we have very complex setups with lots of machines and lots of compute power. But what the normal average company does is you have a primary and you have a high availability machine. One pair, this needs to run. There's no point if that whole data center or the whole building goes away. That's not our concern. We just need that to be running. That will be, for example, the system that manages your access to your office building or the lights in the building. Yeah, there's no point in having a DR in a different place for the locks in your primary office. Yeah, it's if that building is no longer there, you know. But while the building is there, you want to have a system that can take care of that. The other one is you have a primary and you have a disaster recovery in some other place. That's very common. You have two machines, you have a pair, and that's it. And the third one is a combination of the two. You have in your primary data center a pair, and then on the DR side, a single machine. Rarely you see that you also on the DR side have two of them, but hey, we all have to live with budgets, and usually once you're already in a DR situation, you're not planning on running there for a long time and things. Yeah, should it be more? Yes, but again, how much money versus the probability of something happening. Yeah, but Murphy doesn't sleep, so it might happen that when the primary fails, the AJ fails and the DR fail at the same time. Yeah, ask all the people that have CrowdStrike installed. So coming to which tools do we have in the toolbox? And by the way, this slide broke PowerPoint when I made it. Thing is, yeah, because apparently don't animate tables. So SQL 1.0, not even available on Windows, only on OS 2. you could have do backups and restores. Simple choice. You have one choice: do it or don't do it. Yeah? That was easy. In 6.0, they finally added log shipping. You could do log shipping before that, but you had to write the scripts to do it. In 6.0, they finally shipped the UI and the scripts to do log shipping, basically setting up SQL agent, do the backups, do the copy, do the restore. In 6.5, they finally joined Project Wolfpack and enabled you to do failover clustering. Very different failover clustering from today. Back then, in the days, there was no fiber channel where the disks are connected to your servers and you just present them to another server and then it's all done with magic commands. No, back then you had to like have a Y-shaped SCSI cable that went to do two servers, and there were special termination blocks at the end. That thing is, and you needed special firmware on the RAID controllers. And while you were installing, one of the biggest operations was to stop the BIOS because you needed power on the RAID controller, but the RAID controller was not allowed to initialize while you installed the other RAID controller, and then you had to flip it around. And once both were configured correctly, then you were allowed to basically boot both of them. Yeah. Yeah, I would say back then when you installed clustering, your availability went down by like 50%. I had a customer that insisted that we cluster SQL Server and Exchange at the time. I think I installed that system like 10 times a year from scratch because it was just, there was no point in doing this. Yeah, it was just not ready. SQL 7.0 was the first one that supported, and Windows at the time finally supported fiber channel and made that thing so much easier. Even back then, there were no fiber channel switches, so you had to have a fiber channel hub. But even that made it much, much easier. Yeah. So things. But also in 7.0, they added features that are called replication. And they called it transactional replication, which is the most wrong word they could choose for that because it's not transactional consistent. But for whatever reason, Microsoft lists replication as an HADR feature inside of SQL Server, and you will hear my opinion about it in the summary. Thing is, with SQL 2000 and Windows 2000, they enabled something called GeoStretch clusters, which is basically a failover cluster where you have the nodes in two different data centers and the storage system in between replicated the data between the data centers. Awesome. Problem was, if you wanted consistent data, you had to wait for the other side to finish the write. And if that data center was like 300 milliseconds away, each write took like 600 milliseconds. So not really fast, but thing is, 2005, they added database mirroring. And with the last beta version of SQL 2005, I reported a missing feature that we will see soon in that table. And yes, in 2012, always on, with a space in the name and failover cluster instances, and always space on AGs were added, which was basically a more modern version of failover clustering that had better failure detection, and an enhanced version of mirroring that allowed you to have multiple replicas instead of just one replica. Yes, yeah. In 2016, they added distributed AGs, which have a use case. And then in 2017, they enhanced availability groups. And this is when they finally added the feature request that I made in the year 2004. SQL 2017 got a feature that we will discuss at the end of these slides and things. And in 2019, they added useless / clusterless AGs, which are just there for scale out read operations, but not for high availability. But some people have tried to use them for high availability, even if the documentation clearly says don't use them for that. The problem is it's like a gamble. It's like really interesting when you do that. Because if you actually fail over, you have like a 50-50 chance that the database is not corrupt after the failover. So good luck with that. Thing is, and let's not forget that since about SQL 2000, and David can correct me there is VMware Live migrations that you can actually do that. I would say SQL 2000 was the first one where you could have that feature. And while this is not so much of a high availability feature, it's a very good feature for maintenance because you can move that thing around, and that is actually high availability when you do that. So because your client does not notice that this VM got just moved to another host. Yeah. Problem is, if the host dies, yeah, the VM starts on another host. So you're basically rebooting the system to have continuity. So for planned outages, it's great. For unplanned outages, it's not really helpful, but better than nothing. And these days, I would use VM live migrations over failover clusters every day of the week because they are just much easier to configure and they are much better. They just work better in that. So if you need to protect against hardware failures, virtualize and use these migration and HADR tools from things. Would I use them to replicate data into another data center? Not so much. Yeah. Then is the built-in features better? So the first one, when we look at this table is, can I have a copy of my data? And with failover clustering, you cannot. Failover clustering, by definition, has one set of data and moves it between the machines. That means if anything happens to the data, which is on a disk that you literally yank out of one system and then plug it into the other system, which pretty much everybody knows if you ever done that with a USB stick, the data is most likely corrupt on the other side. Windows does a lot of things so that that doesn't happen, but still, I never feel good when a failover cluster fails over. It's just a very fragile thing. Yeah? And also with the VM live migrations, you don't have a second copy of the data because the data also just this thing is. It might be replicated and rated and all that. That's fine, but you don't actually have a second copy of the data. You cannot just split it in two and now have two copies. Yeah? So it's not there. The next one is that data independent from the original data? And with backup restore, that's definitely the case. I have my original database and I have a backup. And unless I put them on the same disk, they are very much independent. Yeah? With log shipping, they are. But the reason I put it in parentheses is if I take a log backup and I restore the log, every error that is on the primary will be also on the secondary. So it's not that much, it's not that independent. Replication is completely independent. It's so independent that the data on the other side might be completely different. And I'm not joking there. Replication does not guarantee the data to be the same on both sides. You can have missing rows, you can have missing updates, you can have duplicate rows, and you can have duplicate updates. So very strange. GeoStretch cluster is not independent because the storage is replicated and then same with database mirroring. Yeah? So you cannot just take it and do something else. This is just one unit. With FCIs, you don't have a second copy. We said that before. And all the availability group things have the same thing as log shipping. It's basically, yes, it's a second copy. But again, if I drop a table on the primary, that table is also dropped on each and every replica. There's nothing I can do. With log shipping, I can easily prevent that by delaying the log shipping. And I have a slide about that as well. But with the other ones, it's just assume that if you have a mistake in your data, it's going to be everywhere. So it's not protecting you from mistakes. It's only protecting you from failed hardware or network things. The next question is, can I have multiple copies of the data? For backup, yes. For log shipping, of course. Failover cluster, of course not. You couldn't even have one copy. Replication theoretical, yes. GeoStretch clusters, no. Database mirroring, no. All the AGs, yes, you can. And over time, the number of replicas increased. And the first thing that was the primary +4. And I think now we are at primary +7 or 8. Even so a 9, I don't know. It's getting up with every version because they're getting more and more comfortable. Technically, there's no reason how many, there's no physical limit or something. They just have to get more comfortable to tweak that number up. Yeah. And with VM live migrations, again, there is no copy of the data, so that's not a thing. Yeah? Now, the thing is that copy consistent? Is the data in the copy if I have 2 copies of the data, is it guaranteed to be consistent? For backup, log shipping, database mirroring, and all the AGs, the answer is yes. For VM live migrations, the answer is yes, if the data stays on the same storage array. If there is storage array replication involved, I would not go as far as that this is going to be the case. And I want to be there very specific in an actual DR scenario. So what I'm talking here about is storage replication is a great thing. And every storage vendor will immediately agree to an DR test, and all storage teams will agree to an DR test as long as it's planned DR test and it's a planned failover. So at some point, someone presses a button for some script that tells that storage array, shut down all the IO on this array and move it over to the other array. If you actually pull the power plug on one of the 2 sides, yeah, and repeat that process 3 times because you have some faulty power that comes and goes, yeah, and your data on the other side is still consistent and correct, you would be the first person that ever encountered that. I've done the test multiple times, and every time the replicated data was corrupt from a perspective of a database. File shares and something, you could not figure out if it's correct or not because there's no way of doing it. SQL Server, Exchange Server, all these things that are based on databases that have checksums across the data, and they actually verify the data when they go online, immediately shows you there is some incomplete writes. Because they do async writes from one data center to the other. And if you just shut down the power, some of these writes end in the middle of them. Why? Because they're usually moving about a megabyte at a time. And there is no capacitor on the world that is big enough to move a megabyte of data from one data center to the other and keep that power on. So it will die somewhere in the middle. Again, if you have planned failovers and everything works great. If you have an actual power outage that comes with like a couple of power spikes or something, I guarantee you this will not work. Problem is, once you have that, which is very, very rare, this is not something that happens a lot, because most failures are just that someone unplugged the cable. It's very rare these days that in a data center there's actually a power outage, because humanity got really good in making power in data centers redundant. It can happen. So very careful. Not all data in all methods is guaranteed to be consistent. And thing is, and the next most important thing is, so we can eliminate the ones we don't want to use, is which one of them uses Windows Server failover clustering under the hood. And that's, of course, is all the failover clusterings and all the AGs except the distributed AG and the clusterless AG. They don't use that. And that's also the reason why clusterless AGs and distributed AGs, when you fail them over, it's about a 50-50 chance that the original database can still be used afterwards. So, which is hilarious. Distributed AGs are an absolute great feature to do DR into another data center. For real DR. It always works in real DR. It gets as much data over to the DR side and you go online. The problem is when you do a DR test under controlled substances, there's about a 50-50 chance that your DR test will fail in the middle. It will still fail over to the other side, exactly as with a real DR scenario. But your failback might not happen because the original database in the process might go corrupt. Because in a distributed AG, if between the moment you initiate the failover and you execute the failover, which are two commands that you have to submit one after the other, if any transaction happens on the primary database after you initiated the first command and then you do the second one, the two databases are different now. Problem is, what do most people or clever DBAs do is they lock everybody out of the system, so they are the only one in there, so no transactions can happen. Great, except for one problem. If you have a really busy system that normally never has time to do ghost record cleanup, guess what kicks in the moment you don't do anything for 1 or 2 minutes on the system and you're preparing for the failover, and then ghost cleanup kicks in and you fail over and your other side has a ghost record cleaned up and the secondary not. It's unbelievable. So distributed AGs, great for real failover, not so great for DR tests. Microsoft is working on it. Maybe in a couple of decades, we have a solution for that. And the reason why they can't fail over is because they don't have the Windows Server failover cluster, because they actually use that to synchronize the data. They use the features inside the cluster to do the data synchronization. And that is, while for a regular AG it works, but for distributed not. Even if a distributed AG is just an AG on top of an AG, and you think it shouldn't be that hard to just synchronize the data. But since they don't require the cluster between them, they can't use the same code they use for an AG. So they had to do something where they do the best they can, but it's not guaranteed. It's hilarious. Good. So let's have a look what you should not use. You should not use the non-always-on failover clusters at all anymore. You should never have used and never should use replication for HADR. You should not use replication at all unless you don't care about the data. GeoStretch clusters, I'm not even sure if there's still hardware vendors out there that will support that, because with the invention of database mirroring, it basically became it was not a thing anymore. It was so expensive that nobody actually really did it, and it had so many drawbacks on the performance thing is, yeah. Database mirroring, while it just works, and if you need something without a cluster that automatically fails over, it still works. It's kind of deprecated. So if you have an issue with it, Microsoft might or might not help you with a support call. I would not use it anymore. I know it's much easier to set up than an AG, but I would not use it anymore. Yeah? I would not use always on failover clusters as well. Again, I grew up with clustering since the very beginning, and even in the last company I worked for, like a year ago, almost 2 years ago, we had failover clusters. These were the machines with the most outages of all of them, because clustering is so complex and doesn't work the way you think it works, that you have, if you don't have cluster experts working in the team, you will have more outages than thing. And if it's issues with network drivers or something else, clusters fail over for no reason. So it's my personal thing. It's my presentation, so I can say whatever I want. If you use them, but I would recommend not. Always on availability groups are great, but don't use them anymore. Don't use the versions from 2012. Use the newer versions. That's the only thing I'm saying. Here, distributed AGs, yes, they're usable. And VM live migrations, again, don't use them for high availability and DR. Use them instead of failover clusters. That's why it's dotted out. Again, if you need hardware maintenance a lot and you have faulty and not very stable hardware, it's a great thing. If you use virtualization anyway, yes, activate the feature that if the underlying host dies, that you get to a new feature. There's no problem, but don't say that's my HADR. Because if the VM dies and you recover, and you, you might have to have some cleanup up there. Yeah. Again, for high availability, I would use them. For DR, not so much. So what remains in the toolbox? Much smaller table now. I put in the column which ones can fail back. So the distributed AG and the clusterless AG, they cannot fail back, or they cannot guaranteed fail back when you do the DR test. And that's a bummer for a lot of people. So if you have regular scheduled DR tests, your DBAs will hate you because they basically they fail over the databases. Half of them go down on the primary systems, and all they can do is take backups and restore them. And again, if you have multi-terabyte databases, that is not a fun job to do over a weekend because there's much more fun things to do. Which one of these can provide zero data loss configurations? Backup restore cannot do zero data loss because you can't do backups fast enough to not have data loss if something inserts after you finish the backup. Yeah? Same with log shipping. Yeah? The problem with log shipping is every time you take a log backup, you have to do a checkpoint. You can technically do it without the checkpoint, but then the log cannot be cleared. So the actual purpose of the log backup is not achieved. So the problem is checkpoints take a certain amount of time. So that's the minimum amount of time you have as a gap and the minimum amount of time you can lose. Problem is checkpoints take more and more time the more memory you have. So when you have a 1 terabyte system, you don't notice that. But if you have like a 6 to 10 or even 20 or 40 terabyte memory system, your checkpoint's going to run half an hour. So you will have problems doing actual log backups frequently enough because checkpoints take a while, because in a checkpoint, SQL Server goes through all that. SQL 2022 improved that. It's one of the things they didn't put in marketing. They now can scan the buffer pool in parallel. So when you have 45 terabytes of memory, it's not one core that has to go through all of them. It can now be done faster. Automatic failover is possible with AGs. And I put it in parentheses because you can only have one automatic failover between two systems. If you have 3, 4, 5 replicas, you have to, after you fail over to the first one, and you now want to have automatic failover to the next one, like I want to go to AJ first, and then from AJ to DR, you have to reconfigure after the first failure. And then what I call drop data protection is that typical, I dropped the table, I did an update without the where clause. Only backup restore and log shipping have protection against that because it happens. You can restore to a point in time before you drop the table. You get all the data out, put it back into your primary database, and you do that. So these are the features. These are the ones that are over. And as you can see, none of them has a check mark in each and every row. So you have to combine at least 2 of them. So having availability groups, same as clustering, doesn't absolve you from taking backups. And since, by my definition, a backup is only completed if you have done a restore test, implementing log shipping makes a lot of sense because you know that your backups are good because every backup from you took, you actually restore in a different system. So what I do, even in the most modern systems where we have like 6 replicas, and it's absolutely and where it's absolutely unlikely that all of them is going to die, what I usually do is I run one log shipping target for the whole company. Some old servers, I put in slow old gigantic disks and just log ship every database there. Yeah, I'm never planning on actually going live with any of the databases. All I'm planning on doing is bring them online, scrap some data out, and put them back into log shipping mode. Yeah? And with that, I had hundreds and hundreds of databases. All you have to do is make sure your SQL agent jobs are staggered and don't start all at the same second, because it's not a good idea to start like 1,000 restores of log files at the same time. Yeah, really not a good idea. give each one 2 seconds to get rolling and then start the next one. Yeah, and so now we have these features, and they all rely on if you want to have automatic failover, and they all rely on Windows clustering to do that. The problem with that is Windows clustering does not work as you want it to do. It never has, and it probably never will. What is wrong with it? So let's take the most simple setup. You have a primary and you have one secondary. That's all you have. And what your expected behavior is if the primary dies for any reason, the other one becomes the primary. That's what you expect it to do. The problem is when you have that setup, what actually happens is in an AG that has two nodes, you have the primary dies, and the secondary dies too. And that is by definition 100% correct. Why? Because two have a working cluster and a node in a cluster being active and running, you need to have more than 50% of the nodes in that cluster up and running. If you have only two, and 2 minus 1 is 1, which is exactly 50% and not more than 50%. So that's it. Luckily, Microsoft had a pretty good idea. You can add a third node. Of course, they're selling licenses. No, they even allow you to use something they call just a witness. So let's build a system with 3. And the third node can be an actual node or just a witness. And for witness, there are many, many options. You can have a file share witness. In the early days of failover clustering, you could have a quorum. Let's not use that ever. And you can have a cloud witness, which is really practical. It's one of the few services in the cloud I actually like. It costs like 17 cents a year based on the traffic you generate. And that file share is just somewhere in the cloud. It's just not done through a file share. It's done through a web service call, but doesn't matter. And it will show it's far, far away, and therefore it's good. So we have the 3. So they tell you have to have a witness, you have to have a third node. So what's my now expected behavior? I run on the primary. I have 3 nodes, actual nodes, no witness, 3 nodes. The first one dies, it goes over to the other one. Yes, because we still have 2 out of 3, which is more than 50%. So they can agree who is the new primary, and we run there. But then what you would think is that if the second one dies, it would move over to the third one. Last man standing concept. Actual behavior is the first one dies, you fail over nicely, that's great. But then the second one dies, and the third one turns itself off. Because again, you have less than 50%. You have 1 out of 3. To fix that, the solution is Microsoft created something called dynamic quorum, which basically means if you have 3 and one of them dies and the other 2 find each other, they say, hey, yes, we're 2, we are majority, we now are the cluster, and since the third one is not here anymore, we now define that we will run, and we only need 2. Problem is with 2, we already know from before it's still not enough. So what you can still doesn't work the way. Right? So and you need things. So dynamic quorum doesn't help you here. The solution for it, and there's two problems. First of all, the dynamic quorum only works with larger clusters when you have 6, 7 nodes and you need 3, 4. With 3, it still doesn't work. And the other reason it doesn't work with 3 is because normally 3 servers are distributed between 2 data centers. That means you have 2 in the same data center, and if that data center goes offline, dynamic quorum can't even kick in. So what you normally have to do is if you have 3, you have to actually add, if you have actual 3 nodes, you have to add a witness. So you have 4. The problem is with 4, if the DR side plus the witness survive, you only have 3. So then dynamic quorum helps you, because if only one of the primaries dies first and then the second one dies later, thing is. still not helping you in the whole thing. The solution for that is you can remove the vote from the normal primary. The normal primary, as long as it runs, will not give up the service as long as it runs. But with an external witness and the other two nodes, you still have only 3. And if now the primary data center dies and the witness is in the cloud or somewhere else, the other 2 are still 2 out of 3 because the primary has no vote. If the DR data center dies, the witness and the secondary, the AJ node in your primary data center are 2 and can take over. So the service will run as it is, because even if the third node has no vote, it will still not change its role when it's there. So the trick is to take one vote away and add a witness. So you actually make it 4 machines, but take the vote away from one. So you have 1 vote in one data center, 1 vote in the other, 1 at the witness at the third location. The easier thing is you have the 3 machines in 3 different locations to begin with. So if a whole location dies, there's always 2 locations surviving. Problem is, again, but this one works because even if one data center is cut off from the other 2 data centers, that's the one that goes offline and the other 2 will go online. So you will have will continue. So, and this is the problem where when you use this and you expect automatic failovers and all this stuff to happen, you need to put in a lot of thought about how the underlying Windows clustering is. And in all my years, when I leave the companies that I work for, they usually have a working solution. But when I come in, it's actually not. Yeah, because everybody, yeah, Windows clustering, next, things. Everything I showed you, like on the last 3 slides, there's no GUI for that. All that is only configurable through PowerShell or the cluster commands. Yeah, that's not a thing that is normally built in. Yeah. And when you have 5, 6, 7 nodes and probably distributed through 4 or 5 data centers, there's always a solution. They built clustering in a way that you can always make it work. The problem is you have to think through all the failure modes. And the best way to do that is do little post-its, big post-its, small post-its. The big post-its are the data centers, the small post-its are the things. Write everything down and then just remove post-its as machines fail and see if everything is still working. Yeah? And with 2 data centers, 1 external witness location, and 3 servers in the primary data center with 2 servers in the secondary data centers, there's 27 different ways this thing can die. And you have to check each and every one that works with the scenario. How would I place the data centers if I could? I have the primary data center somewhere, and I would put in my HA data center, my high availability data center, if I have 3 of them, somewhere less than 1 millisecond away, which is about 150 kilometers or 93 miles. So 60, 70 miles is perfect, because you might be able at that distance to find a different power provider. Especially in the wonky power grid in the US, you might actually find a different company. So if one power grid goes down, the other one doesn't go down at the same time. And it's usually fast enough, far enough distance so that things like flooding and snowstorms will not affect both of them like at the exact same time. They might be both affected, but there might be like a minute or 2, and that's all you need. Because the third data center is at least is far away, at least 800 kilometers or 500 miles away. That's usually atomic power blast radios. I find this hilariously stupid, because if an atomic bomb goes down on your primary data center, I guarantee you have 1,000 things that are more important to do than fix your company's DR site. Or and be honest, where are all the data centers in major cities? So it's very likely that the other one got a bomb too. So it doesn't matter. But again, thing is, I like to have them in different environments. So if one is in the desert and the other one is on the coast, it's great. So if you have a flooding, one goes down. If you have a drought, the other one goes down. Uh, no, it's tornadoes and floods that are the thingy. You don't put them both on the same coast. Don't put them both in the same tornado area. Yeah, even if they're far enough away. Things. So last resort, far, far away. Let me put it this way: about 20,000 miles is a good distance. Yeah, so buy a globe, put a pin in, and push it all the way through the other side. Wherever it comes out, that's a good place for your last resort. Yeah. So if you are in the US, Australia sounds really great, or Japan. Yeah. If you're in Europe, yeah, that's a great place to put your servers, your last resort option. What is last resort? Once a month, you take a set of backup tapes, you put them in a box, and you ship them into a storage facility. That's all what your last resort has to do. Yeah, because again, remember, you're starting from scratch. Yeah, you're going to the other country, which you most likely have to do anyway, because whatever is in your country is already gone, everything. So you go there, you dig them out, and you restart the company. Yeah. If you have really important data, you send that package every day. Yeah? And I worked for a company where every day we had to restore about 6 terabytes of data on a laptop. And then one of the executives, every day a different guy, was coming by a couple of minutes after 5 p.m., pick up that laptop, and disappeared with it. And we've never seen it again. And next morning, IT has delivered a new empty laptop to our desk. And by the evening, we had a backup of each and every database. That we had a very small list. We had like 10,000 databases, and they needed 7 or 8 databases on that box. And the definition was, if everything is gone, all we need is that laptop to start the company again. The normal office team copied a bunch of file shares there and stuff like this. This was everything needed. And every day, one day it was the CEO, the next day the CFO, CTO took that laptop home or wherever they put them. I have no idea. Yeah. Did they put them on a ship or buried them in the backyard? I have no idea. Yeah. What we knew is we had a new serial number every day. Because after a while, we're like, yeah, they're recycling them. Nope, they're not. Yep. So whatever happened to them, I don't know. And again, if a company makes a couple of billions a year, a $2,000 laptop a day for having a chance to restart the company is not a waste. Yeah. Some money saving options that I successfully implemented. If you have an active passive thing, you can make the passive node a read-only node. And offload your read data, your read request to the other side. In case of a HA or DR, you lose that, so you then down to the normal performance, but it will help. Careful with licensing, that might affect it. What I do a lot is what I call shared DR. I have 2 primary systems that are completely independent, completely different databases, and then they share one DR system indicated by that color shading thingy, blue and the normal color of the Visio shapes. So basically, in a DR scenario, we're running at half the capacity. Still the same size of disk. So if each one of the primary systems has a terabyte, the DR system needs 2 terabytes, but the primary systems, each one has like 10 cores, and the DR machine also has 10 cores. So during a DR, everybody understands everything takes twice as long. It still works, but it will take a little bit longer. Yeah? And another one is shared AJ, because it's very unlikely that AJ actually kicks in. So what I do a lot is that I have 2 independent primaries. They have their 2 independent DR systems, and then I share an AJ on one side. Again, same thing as the shared DR, double the disk, everything else is the same. Do we sometimes use that as a read-only replica to read from both of them? Sure, why not? But everybody understands that, okay, there is the very low chance that both of the primaries die at the same time. Then we have slower AJ. We can choose to go to DR and get back the normal performance. If not, we just save the whole machine out of 6. Yeah, so that's a significant 15% discount. So HADR, we're coming to an end. Backup restore must be combined with all the others. There's no excuse. Again, we're now in 2024, soon 2025. We're doing databases for 50 years. If you didn't get the memo by now that you need backups of your databases, I cannot help you anymore. There's no excuse. I don't have a budget. I don't have anything. If you don't have backups, turn off the systems. Yeah, because at some point it will bite you. Yeah? One more anecdote. I worked for a big company. We had about 900 SQL servers. And one day I got an email, corrupt page. Okay, can happen. I got another email. I got 8 million more emails. 8 million corrupt pages within like an hour across all databases. Yeah, I mean, you're like, okay, two options. A, Microsoft fucked up SQL Server somehow. B, something on the storage system has a problem, which was the case. It took us about a day to figure out what actually happened. It was a problem. The manufacturer of the storage system shipped a driver that was not working properly for the VM host. So the VM hosts had fiber channel drivers for that array. And what they basically did, a normal fiber channel driver sends the write request, and then it gets back, yeah, it's okay. Or it gets back, no, you need to retry that because there was a problem. You need to retry the write. And that happens a lot, about 8 million times within an hour. The problem is, if the driver says, yeah, I got this error message back from the array, well, yeah, I don't care. Then you don't write. And the reason we could prove that is we had the write errors were blank pages. So every corrupt page was a completely empty page because SQL zeroes out the pages when it uses them first. So what's on disk was basically the zeroed out page. And then there was no page header on it, nothing. It was 8 kilobytes of zeros. And that cannot happen because when you take 8 kilobytes of zeros and add the checksum is not 0. So you have to have at least 8 bytes that will give you the page checksum that is different. And that was also 0. That means the write never happened. Because that's literally the last line before the write actually does it. They insert the checksum. And therefore, we could prove there was none. And we also had corrupt log files that also had X bytes of absolutely nothing in them. And so that was fun. We recovered everything. It took like 3 days or so till everything was back. But that was fun. Yeah. I was not there when the discussions with the lawyers started with the manufacturer, but that must have been a fun one. Yeah. Log shipping, you should be combined. And again, this is to test your backups. Just restore them somewhere. Yeah. Automatically set it up, and log shipping, unless you mess with it, once it's set up, it usually runs for years without any issues. If you constantly break your log chain, that will teach you not to do that. Yeah, don't turn off, don't switch things into into no recovery, simple recovery, all that. Yeah, don't do that. Yeah. It's some extra work required when you do it with always on availability groups, because you have to you have to manually move the jobs and duplicate the jobs to all the nodes and put some logic in it that you take only log backups on the current primary, because otherwise you end up with very weird log scenarios when you constantly do log backups on 2 systems. at the same time, because then you have you still have only one log chain, but you might store them at different places, and that might then lose the log chain. Must be taken from the secondary after failover, which is now the new primary. Putting always on availability groups on top of a cluster, on a failover cluster, and I've seen this, like 2 failover clusters and then an AG across them. If you plan on only doing automatic failover, that's great. Only manual failover, sorry, I misspoke. If you only try to do manual failover, that will actually work. If you try any form of automatic failover, both on the cluster or on the AG level, it's not doing what you expect it to do, and you can't make it do what you want it to do. For example, if the cluster, the FCI fails over, the AG will fail over as well. Because cluster failover, you have an outage, the whole instance is down. It takes more than 10 seconds for the instance to come back. SQL recognizes that and fails over the AG to the other cluster. Yeah. Same thing. It's just, unless you plan everything manual, you just want a lot of machines and people can play with them. It's great. Don't do it. This is where the virtualization is much better. You want hardware protection, use virtualization there and let them deal with all that, because then it's completely separated, and they can fail over between planned failover between 2 nodes or 2 hosts without AGs even noticing it. They will notice it, but it's not long enough for them to actually initiate a failover. Yeah, and as I said, if you do automatic failover and clustering, you will have double failovers all the time. It's not a good idea. 2 or 3 things I mentioned through the whole thing. Delayed log shipping. What do I mean with that? This is one of the most underutilized features in log shipping. It's there since SQL 6.0. It was in the very first version. There's one field in the config dialog that says restore delay. The default is 0. Don't delay the restore. And yes, to test your backups, you want to restore them as quickly as possible. So what I usually do is I take my log backups every 1 to 30 minutes, depending on activity, importance, whatever. Yeah. Most of the time I do about every 5 minutes. Some things every minute, 2 minutes, 30 minutes is rare. I have machines where I put in some logic where I actually check how much is in the log. And if there's only a couple of bytes, I don't take a backup. I only do that if I have an AG. So I have the data at least on one other machine if the primary dies. But again, you take backups regularly as quickly as you can. That's fine. Yeah. And you restore them on the first server immediately to test the backups. That's the thing is. But then you add a second log shipping target, and then you delay somewhere between 2 and 8 hours. And that could be some completely other number. That depends on how fast can your business figure out that they messed something up. Is it like, okay, sometimes a developer drops a table in a rollout or something, you immediately know. Yeah. This is where the more like 2 hours is better. Because what you can do is, in case you delete data or you destroy data by updating it to uselessness or something, you can restore the second log shipping machine till a few seconds before that happened, and then bring it read-only online and pull out the data. And you don't have to restore the whole database, bring up the logs. It's already there almost. Yeah? And when do you want 8 hours? That's when it takes longer to figure out. When you don't figure out that something's wrong before the end of day, you might have to put this into 12 hours. But it's still better to have a restore that is about 12 hours old, already there, and you only have to apply 12 hours of logs. Then you have to start a restore fresh to get there. Right? So this is the thing is, it's really great. And I had a couple of companies where we used this all the time, because my experience is dropping and updating a table in the wrong way happens way more often than hardware failures. If hardware or something fails, yeah, it's usually a bigger blast radius, but the other one happens much more often. Yeah. And again, the second server and even the first server can be old, slow, just needs decent disks that can still handle the I/O. And today, everything you bought in the last 5 years can handle that I/O. And as I said, one can be enough for the whole company, and that could be an old. And since none of these databases is online, and you only need it in a DR scenario for a couple of minutes, I'm pretty sure you can negotiate with Microsoft that you don't need a license for that machine. Yeah. If you go just by the papers that Microsoft went out, and more than once every 90 days, you bring that one of the databases online, you need a license. But I'm pretty sure you can negotiate with Microsoft that you don't. Yeah. And that's a side letter to your license agreement, and everybody is happy. Yeah. Because that's not a hill Microsoft wants to die on. Just take your sales rep on the side, buy him a beer, have a nice discussion, and I'm pretty sure you can negotiate that. Multiple databases. Something we haven't touched on. If you have your data in more than one database and they need to be synchronized, so you're actually doing the overhead of having distributed transactions between them, you need to have a plan. If you have to roll back one of the databases, what are you doing with the other database? Are you rolling back the other database as well? And where are you rolling it back? The problem is Microsoft built the feature in, but nobody uses it. So the problem is when you have two databases and you have a distributed transaction that inserts data in both of them or moves data from one into the other, deletes it here, inserts it there, whatever they do, when you restore them, and you restore them both to the same point in time, even if the clocks are 100% synchronized, which they never are, yeah, but even with that, you still might have one transaction that gets rolled back on one side and the other one not, because in that point in time, one side might already be done and the other side not. So in one, you have an in-flight transaction that gets rolled back and the other one is committed already and not. So the problem for that is it's a feature. It's in SQL since 1.0. It's called named transactions. Whenever you do a transaction, a distributed transaction, give it a name. One number that you count up, the time, something that's unique. Yeah, because you can also restore up to that name. And then you would have the restore on both sides to the exact same transaction. Yeah, and you have to do that. And that you need something that you need to plan upfront. Yeah. In most places, it's good enough. You restore them both and then you somehow synchronize the data manually between them, or you understand that, or you handle it in the reporting. It's just something I want to point out. If you actually have financial information in one and more database and you're transferring from one to the other database, you need to have a plan how to restore that stuff. Yeah. That is still a problem in 2024. Solution, simple one, put everything in one database. Yeah, I did not say that. Don't do that. Yeah, but because that database will grow very, very big and will be unmanageable. Yeah. What you can try to do is put all the data that needs to be 100% transactional consistent into one database and put all the other data into other databases. My example is always eBay. eBay can have whatever database they want for all the bidding. But for the winning bid, they insert it still into a big Oracle database. Everything else is some magic NoSQL. Yeah. But the winning bid immediately goes into the relational database for the whole website. And one tiny little database is enough for the whole website, because what happens is billions and billions of bids and a couple of 100,000 actual final winners of the bidding war. Yeah. So to think about that, it's not easy, but you need synchronization points for the point in time where you recover, and that's named transaction. Nobody's doing that. I could never convince anybody to actually do that. But it's necessary. or you have a way of getting them into a consistent state afterwards, yeah, by either deleting data on one side after you restored them, or being able to ignore it in a data warehouse loader or something. Another thing that is absolutely necessary in every system is a prioritized list of all systems. It's like a prenup for your servers. You need, while everybody is still in love with each other and everybody is willing to go into a room and negotiate, you need to come up with a list of each and every server and in which priority they get recovered if more than one dies at the same time. If you don't have that list, you will waste 90% of your first 3 or 4 hours of your DR scenario or of your last resort scenario or something, just negotiating which one we're doing first. And that's just time you don't have at that point in time. Normally, one system fails, it fails, you deal with it. Doesn't matter where it's on the list. 2 of them fail, you have 2 DBAs, each one deals with one of them at the same time. Problem is, you need to manage your resources because you only have one DBA that is working, or your backup solution can only provide one file at a time or something. And yes, there are stupid things that can only do that. You need to have that list. And that list needs to be renegotiated at least once a year, better once a month, that everybody signs off. We're still happy with it because things change. There might be one server that is completely, nobody needs it. And 6 months later, it's the one thing that the company makes money with. So that goes there. This list can be different depending on the point in time. The priority list during the week might be completely different than on the weekend, or on the first of the month, or on the last of the month, or on tax day, or something like this. That can be there and that can be handled. But again, negotiate that when you have time, when you can do hour-long and day-long meetings with 15 departments. Don't do it when you are already under fire and everything's burning around you. It's not a good time to do that. Yeah, it sounds like super simple. You print that list out, you like all the other like HR things, and you put it in the coffee room or something so everybody can see it. It's not a secret, and nobody can say we had no idea it existed. And have everybody sign off on it as often as you can. Zero data loss. I already thing is, when I got SQL 2005, the beta version, I immediately put in a request with Microsoft because they were missing a feature. They had the high performance mode, which was async. They had the high safety mode, which was synchronous, but they had no zero data loss mode. What does this mean is, the problem is, before SQL 2017, there was no option to handle the zeros because all that Microsoft thought about was, what happens if the primary dies first? Can we build something synchronous? So if the primary dies and we fail over to the secondary, we don't lose any data. The problem is, when the secondary dies first, the primary for 10 seconds tries to connect to the secondary. And if it can't do that, the primary just continues. Same with mirroring, same with AGs. So if a secondary dies, doesn't matter if it's async or sync, you have a 10-second delay, which basically is you're failing over from one machine to the other, or you're rebooting or restarting the service that normally fixes itself in 10 seconds if you don't have major rollbacks or something. And the reason, and then they continue. So if your secondary dies first, the primary continues to commit transactions, but you have no copy of them in the other data center or the other location. And then the primary dies, and then you can only bring the secondary back online. You lost data. And that cannot happen. And finally, 2004 to 2017, so only 13 years, took Microsoft 12 to 13 years to add required synchronized secondaries to commit to availability groups. I think it's the longest option they ever created. I know because I had to change one of my tables to actually put that thing in because I was cutting it off with less characters. And the default value of 0 is the old behavior. So we don't actually require a secondary commit, even if we are synchronous, which is hilarious, but thing is, but only if the secondary is not there. If it's there, it must commit. But if it's not there, we don't care, which is not a good data loss concept. Thing is, but if you have a value of 1, 2, 3, or whatever you have is, that many secondaries must actually commit back. Thing is, so if you have, for example, 3 servers, if you have 3 nodes, and you put the value of 1 in, that means the primary plus one of the other 2, doesn't matter which one, must commit that transaction. And it can only commit the transaction if it has all previous transactions. So even if they flip-flop, it has to catch up all the time before it's valid. And with that is, if you would set it to 2, that means both of them have to do. That's like, you really want 0 data loss. But that also means if either one of the 3 fails, the whole thing fails, which is probably not what you intended. So I would always set it to 2 minus the number of total nodes I have. So you need the primary to be out of the game, and then 1 machine that can fail, because otherwise you have a lot of downtime for unclear reasons. Thing is, but it took a while, but it's now there. It's still, you can still create artificial ways of like losing data. And yes, if all your data centers plus your last resort and every backup gets destroyed, yes, you lose data. And that option always exists. There's no way around it. But if you're reasonably careful, you can pretty much guarantee that you have 0 data loss with that. Yeah. Can a human still mess it up by dropping the database on all servers and something? Yes, but again, assuming everything else is done correctly as well. So I think 4 more slides. When you build high availability solutions, you have to figure out what are my dependencies. This server depends on the database server, on a mail server, on a file server, and whatever, an Active Directory, and the one database server depends on another database server because you are still using linked servers and stuff like this. Yeah. And then all of them depend on the network switches, and they all depend on power, and they all depend on your HVAC system and 3,000 other things. Yeah. The problem with that is, this is the math formula that calculates your total availability based on all the individual abilities, just assuming that all these things have by itself the same availability, because with hardware, availability is a guessing game. Yeah. Some things are better, some things fail more often, some things fail less. What I've learned is I did a lot of super complex calculations and did each one of them, and really thing is, and then I just did a guess with like an average value across all them, and it's about like 6 digits the same result. So doing 3 days of math or just guessing a number is about the same thing is, and I use this simple table. Yeah. So I assume every individual device has an availability of 99.95%, which is about like 2 or 3 hours. When it fails, it takes it 2 or 3 hours to fix it. Yeah. But if you have 2 of them that depend on each other, you're at 99.9. And then, for example, if you are at 9, you are already at a downtime of 38 hours. So if you have if one thing depends on 9 other things that all need to be running for this thing to work, your availability is really bad already. Yeah? Luckily, if you have 45 things, that's 8 days. Probably you will not fix that problem, but whoever replaces you in your job will do that. But thing is, yeah. And the second one is, if you have one, you add a redundant system. So if one fails, you can connect to the other one. Yeah. So if you do that, again, the math to do that, the first one is if they have all different availability. The second one is a simplified one if they all have the same availability. And again, if my original availability was 99.95, so if I have just one layer and then if I have the last one, which is the 8-day one, even if I put like a couple of them, if I put like 4 of them that each one takes 8 days to fix in parallel, I'm back to like 6 nines of availability. So even if they have each individual has a real crappy availability, if I just have 2 of them, I'm much better off. So where I'm getting with that is, and this is where the difference between 2024 and 20 years ago comes in. In 20 years ago, the concept was make each and every server as available as you can. Because that's the thing is today, and this is what the cloud is doing, but the problem is you can do it in your own data center. You rather have 2 crappy servers stand by each other than one great one. And 2 crappy ones cost way less than one great one. Yeah. And this is where FCIs and everything doesn't make sense. I rather have a 3-node AG with non-redundant disks in each one. So I have 3 copies of the disks in 3 data centers. And I need only 1 license because since 2019, I can have 1 license for AJ and DR. I can use the 1 license for all 3. So I need 3 times the hardware and 3 times the disk and 1 license. Versus if I do a failover, a redundant disk on each side, which means I need still 2 data centers at least, because without that, I don't have a DR. So I have now redundant disk in each one of them. So I need at least 4 times the capacity to have the redundant disk. And RAID 5 is not redundancy. So RAID 1. And I still need 1 good hardware on each side. And like redundant hardware with complex network cards and array and HBAs and everything double and triple, and redundant power supplies and all that. That thing is probably cost more than the 3 machines that I just put in the 3 data centers. And so these days thinking, because if you look at absolute crappy individual availability of 97%, which is like, that's 8 days off a year. If I put 3 of them in, I have 99.9 theoretical chance. That's less than an hour. Yeah? So that's good enough for most people. And it costs way less than putting 2 servers that can do 99.7. And 99.5, like the first column, a server like this, that by itself has that availability, is insanely expensive. So choice of hardware, you can have fast and cheap and lots of them, or slow and expensive. And then funnily, there are super redundant servers that need storage arrays and all kinds of fancy things. They're usually slower. Yeah. For example, in a fast and cheap machine today, off-the-shelf AMD server with 1 CPU, bunch of SSDs in there, can do 240 gigabytes per second backup and restore without even thinking about it. Yeah, 24 drives, 24 SSDs cost nothing. That's $30,000. You're not getting any storage array for $30,000. Yeah, and then they have a speed of 2 gigabytes, or some of them have like 8 or 9 gigabytes these days. But that's where they tap out. Yeah, and that's the question. Yeah, and even low-end machines have easily 15 to 70 gigabytes per second. Yeah, and your availability is better because I guarantee you will have more cases where you have to restore a database that needs to go quick than you will have failed hardware. When I started 30 years ago, hardware was the #1 failure. Why? Because CPUs still had vibrating coolers on top of them and were literally falling out of the motherboard. Yeah, I had that more than once. Yeah, that was how servers were built 20 years ago. Nobody does this anymore. The manufacturers of servers have an incentive to not have warranty issues. They built the servers that they run for thousands of days without any failure. Yeah? When I started, the lifetime of a server, everybody was complaining that you can only write the server off in 3 years. You couldn't write them off faster. Yeah, because everybody was like I want to replace it after 2 years. Today, 10 years for a good server is not an unheard of life cycle. Yeah, they're not enhancing that much anymore. Yeah, so you have to rethink this a lot. So what is not high availability to round up the whole thing? It's not a feature you can turn on. Yeah, it's a complex thing where you have to negotiate and adjust and configure hundreds of things. It's not a button you can press. It's not like the AC in your car on off. I wish so, but it's not. Yeah. It's not an appliance you can buy. I wish there is. Yeah, it's not. Yeah, because it just doesn't work that way. Yeah. And it's not extra hardware that you just put in a corner and hope for the best. Yeah. It doesn't hurt if you have the extra hardware, but it's not, that doesn't give you high availability. And it's definitely not 5 nines. I know I use the percentage myself, but I never define availability by nines. This is used if you get paid by it. That's a different story, but not that. Everything is a compromise, and you reduce the risk till it becomes acceptable. Yeah. And again, I worked with machines where it's like, yeah, if everything dies, we get a new empty database and we're fine. If everything dies, yeah, we download the data from Bloomberg again and put it in the database. It's fine. Yeah. Other data, if we lose that, we don't have any copy and we're losing that amount of business. And I had systems where that number, I worked in companies where the company actually could put a number on the minute, how much a minute of outage was. And at that time, and this was 20 years ago, a minute of downtime was 76,000 euros per minute. So basically, if we could get a system back online 10 minutes faster, we were talking €500,000 saved for the company. So with that number, when we plan the system, we could say, okay, we can build this one that takes an hour to come back. It costs $50,000, or we can build this other one that costs $1 million and it's back online in 10 minutes. And then the 50 minutes difference, you multiply it by 67,000 euros. And if this is more than $1 million, you probably do it. If not, you ask around where it is. Yeah. But that's what it is. So that's all I have for today. It only scratches the surface of the whole thing. I'm more than happy to help people if they want me to have a look at their environments or something to see where they are and if what they are thinking is actually what's happening. I might not catch all the problems because some of them I learned the hard way by trying it one way and then changing it to another way. But I've configured probably several thousand cluster environments over the years, and I did a lot of testing. I was lucky over the years that I always worked for companies that actually wanted me to test that stuff. It might also be that I declined offers from companies that were not willing to test. But the thing is, so thank you very much. Here's my email address. I usually answer within a week, and the trick is I usually answer on the weekends because that's when I have a little bit time. So if you want to have a great experience, you write the email to me on Friday and you have an answer by Monday. If you write me on Monday, you also have an answer next Monday. Just a tip. No, just sometimes I answer immediately. Sometimes it takes a week. We're all busy. Thing is, I'm happy to talk, help you wherever you can. If you have any questions, just feel free to ask now or send me an email. If it's now, it's on the recording and other people might benefit from it. If it's per email, it stays between us. Unless I use it as a story. But as you could see, I never mentioned a name of any company because thing is, I mean, if you go into my LinkedIn, you can probably figure it out, but
You've worked with enough folks, we could guess, but we don't need to. You've worked with arguably some of the biggest systems in the world for your entire career. It's just incredible.
Yeah, got lucky. It's all luck. And the only reason I'm with SQL Server is because when I was still a developer, we got the specs from the company that they expected 300,000 records in the next 10 years for the system. So the whole system was based on a FoxPro database. Once we shipped it, we got a call about 3 or 4 weeks into the system running that they got a warning that they are out of capacity, because within 3 weeks they had 300,000 records in the system, and it was very clear that FoxPro is not going to be able to. And for people who don't know what FoxPro is, there's excess, and below excess there's it was called DBase, and FoxPro was like a clone of DBase. It was a little bit better than DBase, but not really. But it's way below excess. Yeah? So it was not meant for large data. It was meant for the recipes and the address database of a small company. It was never an enterprise product. Yeah? So we basically had an emergency that we had to find a new database backend, and yeah, FoxPro had a backend interface into SQL Server at the time. So the application was still talking to FoxPro, but FoxPro was not using its own storage engine. It was using SQL under the hood. That gave us about 3 or 4 months to rewrite all our code to work against SQL. So we had 3 months to become SQL experts. At that time, Windows was still 16-bit. So the biggest challenge was to get the client's 16-bit operating system talk through ODBC to a 32-bit server. And Microsoft support could not figure out how to do that. So, but we did. It works, actually. So it was hilarious. And if you ever wonder why, when you read from SQL Server, you only get 64 kilobytes at a time when you read a blob, that's still a leftover from the 16-bit world time, because you could not process more than 64K at a time. This is why when you read a blob, you have to do it in 64K chunks, and it takes forever to get a blob to the client. It's there forever. So again, I'm discussing questions. I hope people have them.
There are no questions in the chat window because you answered everything and then some. If anybody has any questions, either come off mute and ask them or drop them in the chat window, and we are happy to stick around as long as we need to answer, because this was, not only was this phenomenal, but this should be at the core, really the core tenet of every DBA on the planet. And if it's not, it better be soon. This is your job.
Yeah. Now, the problem is, every DBA these days needs to be a Windows clustering expert for SQL Server, and they are not.
And a
because
networking
it's
expert.
nobody teaches that anymore.
Yeah.
Because they thought clustering was an FCI problem, and we're not doing FCIs anymore. We're doing AGs. Therefore, I don't know. It's even more important with AGs because the scenarios are more complex. FCIs were simple: 2 nodes, 1 witness, a quorum device. Yeah, it just works. Something fails, you go to the other one. If you have, the largest server I ever had was 16 nodes. Yeah, defining the failover priority for that thing, insane. Yeah, but it's necessary. Yeah.
Yeah, that was your intro to SQL Server. Mine was I took a job as a backup DBA because I had dabbled in SQL Server and a primary system admin, and day 2 on the job, the DBA quit. I had 6 months to get 7 performing arts organizations onto the same ticketing system for a $100 million performing arts center that was being built. Go, or you're fired. Okay. I don't think we have any more questions. This was phenomenal. This honestly should be required education for anybody looking to be a DBA, and required refreshing education for anybody who's a current DBA. This is arguably the number 1 tenet of being a DBA. It's protect your data. Performance comes second. It's close second, but it's definitely second.
The big problem is that with each one of the slides and everything I touched here, there's another full presentation just on that one detail.
Well, we'll have you next month, right?
I have no problem with that. Just shoot me an email, but probably not every month, but every couple of months, let's go into each detail because I have the information. The slides might not be as pretty, yeah, or something, because the more you go into the detail, the more it gets gruesome and thing. But I can dig out documentation that I can share with the public or make it in a way that I can share it. Like, as I said, this is like 50 pages documentation that 27 ways 5 servers can fail, in which order and what can fail, between them and everything. Yeah. And back then, I don't know who still remembers Mike Steinecke, which was one of the few cluster MVPs that are out there. Now he unfortunately works for Microsoft and does useless stuff. But I was sitting with him for like a week and I hired him at that point, and we were going through each and every one of these scenarios, ensuring that the configuration and the setup we had would actually work. Because the problem is some of them are really hard to simulate. Yeah, I mean, shutting down a whole data center, it's really hard to get permission to do that just to test something.
Yeah.
You can convince the network team that they like turn off your switch ports or something, but that's a different failure.
Mm-hmm.
Yeah, it's close, but it's not the same. Yeah, it's as I said with it's very different if I shut down a storage array or if I pull the power plug. And it's even more different if I take a baseball bat and hit the power supply till it fails. Not that I will ever admit that I've done that, but
There's a number of creative stress tests that you and I have done that shall remain nameless, but they are always hilarious.
one of my favorite tests that I do with every new server type I get is the blow dryer, the hair dryer that I bring, and all the air intakes get a blow dryer in front of them. So instead of getting chilled air in there, I get like really hot air in there, and then I see what the server will do. I do not expect the server to survive that. Yeah. But I expect the server to do something. Yeah. I hope it will send me an alert in some way and then shut down. Or it will run till it something in there melts. That's also fine, but at least send me an alert up front that you're overheating, because CPUs are designed to run at about 100 degrees Celsius, so somewhere hotter in US measurements. But yeah, once you get them to 200, they start failing. And
Nice.
also, a hard drive fails very different if you just plug it out. The stupidest RAID controller can recognize that. If you start vibrating it for an hour, that's a whole different death. Yeah. Or if you start heating it up so that you actually make a head crash, because the platter expands more than the carrier arm. Yeah.
Or compress
Yeah.
it with a car.
Yeah. No. Or you figure out how the wear leveling on your SSD works, and then you do the exact opposite of what to force it to die. And you see what happens by writing a pattern that is not natural but will make it die. And instead of taking it 6 or 7 years in the real world, you can make that thing die in like 50 minutes. Yeah. And yeah, and you have to talk to your hardware vendor, because when they give you a loaner system to test it, you make them clear you will not get them all back. Some of them will fail, and some will be destroyed in that test, and I'm fine of paying for that. Yeah. But it's something that needs to be done, and not everybody, and I fully understand that, can do that. And I try to share as much as I can, and yeah, if you want me back, I'm always happy to produce something. We might have to do PDFs instead of PowerPoints to go through the stuff, because I might not have the time to make it into a PowerPoint. But
Your experience with crayons and newsprint would be sufficient.
sugar
I,
packets.
they, we
No,
have had that conversation, and it's been phenomenal.
this is how availability groups were born. I remember sitting there with like 2 or 3 other MVPs and Microsoft, 3 or 4 Microsoft people at Pass Summit at one of the lunch tables. We collected all the sugar packets with all the different colors from all the other tables because they wouldn't let us use like pens on the tablecloth. So we had to come up and we built up scenarios with sugar packets and explained to Microsoft how we would love availability groups to work. And unfortunately, I had to delete the 2-hour video after sending it to Microsoft because technically it was under NDA. But it's hilarious. We even thought about giving a presentation by replacing all the Visio icons with sugar packet photos of sugar packets. But Microsoft did not agree to that. But
Aw.
that's how things are born. This is you use whatever you have. Yeah. And
Yeah.
again, I write my documentation in a tool called LaTeX, and yeah, I'm that old. Uh,
It's one of the best things out there. Why say you're old? It's
yeah, but it
simply
has
a
a learning
mature,
curve that is unbelievable.
yeah, but it works great.
It works. What you can do with this thing these days is unbelievable. And ChatGTP also understands how it works, so it makes life much easier. So
Well, tell you what, let me go ahead and kill the recording here. If anybody's watching this after the fact, thank you for sticking around. If you have any questions, you've got TG's email address up there. If you have any questions, do not hesitate to reach out. Contact him, contact me. Honestly, if there's anything you want to see as a future presentation, let us know. We're nerds. We have a lot of fun with this stuff. So thank you, and we look forward to the next one.